Hello everyone. Today we team 1 comprising myself Dr. Suman, Isha Kulkarni and Sudhakar T under able guidance of Professor Hesef Choksi will be presenting our capstone project titled AI driven insurance risk assessment and policy recommendation system. The goal of this project is to use machine learning, explainable AI, and large language models to predict insurance claim risk and recommend appropriate policies. Our system not only makes predictions but also explain them in transparent and user-friendly way. Next slide. Insurance companies rely heavily on accurate risk assessment to determine pricing and policy coverage. However, traditional methods are often manual and rely on basic statistical techniques which fail to capture complex relationships in large datasets. This can lead to incorrect risk estimation, resulting in financial losses for companies or unfair pricing for customers. Additionally, these systems lack transparency, making it difficult to explain decisions. So, the key question we address in this project is: can machine learning accurately predict claim probability and help recommend the right insurance policy? Next slide. To address the problem, we developed an AI driven end to end system. First, we take user input such as policyholder and vehicle details. The machine learning model predicts the probability of a claim, which we interpret as a risk score. This risk score is then converted into categories like low, medium, and high risk. Based on this, the system recommends an appropriate insurance policy, which can be basic, standard, or premium. To ensure transparency, we integrate explainable AI techniques that identify key contributing factors. Finally, a large language model generates easy to understand explanations for users. Next slide. The dataset used in this is the car insurance claim prediction dataset from Kaggle. It contains over 58,000 records with 44 features describing policyholders, vehicles, and safety attributes. The target variable is binary, whether a claim was filed or not. One important observation is that the dataset is highly imbalanced with far fewer claim cases compared to non claim cases. This makes the problem more challenging and requires careful handling during model training. Next slide. We performed exploratory data analysis to understand patterns in the dataset. One of the most important findings was the policyholder age shows a clear relationship with claim probability. However, many other features such as vehicle age and safety features showed weak and inconsistent relationship. We also observed strong correlations among vehicle related variables indicating multicollinearity. Overall, no single feature strongly predicts claims, which suggests that this problem requires machine learning models capable of capturing complex feature interactions. Next slide. To solve this problem, we selected multiple models from different categories. Logistic regression was used as a baseline because it is simple and interpretable. We then used random forest and XGBoost, which was powerful tree-based model capable of capturing non-linear relationships. Additionally, we included a new neural network model, specifically a multi-layer perceptron, to evaluate deep learning performance on tabular data. This approach allowed us to compare different modeling techniques and identify the most suitable model for our dataset. For further slides, I hand over to Isha.
Hello, this is Isha Kulkarni, and I will be taking over. All right, so before training, we cleaned the data by removing irrelevant columns. We standardized the numerical features and used one hot encoding for categorical variables. We built everything into a pipeline. To keep transformations consistent and avoid data leakage. Since the dataset is highly imbalanced, we used class weights to give more importance to claim cases. We also tried Smooth, but it didn't improve performance and added noise, so we didn't use it further. Uh, Coming to model training and evaluation, we used a stratified train test split method to maintain class distribution. All models use the same pre-processing pipeline to ensure fair comparison. Because of class imbalance, we focused on recall and ROC AOC instead of accuracy. Accuracy can be misleading here since predicting all non-claims would still look good. So recall is more important as it measures how well we identify actual claim cases. Coming to model comparison and final selection, we compared multiple models and saw clear differences. Logistic regression worked as a baseline but was limited. Random forest performed the best overall, balancing recall and precision well. XGBoost was similar, but it didn't show any significant improvement. MLP performed poorly, likely due to the imbalanced tabular nature of the data. So we selected random forest as our final model. So with the end-to-end system architecture. Here is the flow. So user input goes through the pre-processing pipeline and then into the random forest model. The model predicts claim probability, which we treat as a risk score. This is converted into risk levels like low, medium, and high. Based on that, we recommend an appropriate insurance policy. We also use explainable AI and an LLM to generate clear, user-friendly explanations. Uh, Coming to results and model performance. So, our final model was random forest. It performs very well on non claim cases, but identifying claim cases is more challenging due to imbalance. We also observed a trade off, improving recall increases false positives. From the confusion matrix, we can see strong performance on non claims, but some missed claims and false positives. So, the key takeaway is that the accuracy alone is not enough. Recall is critical for this problem. Explainable AI and LLM based assistant. A key contribution of our project is combining explainable AI with an LLM. Explainable AI helps identify which features influenced each prediction. Then the LLM converts these technical outputs into simple human readable explanations. We use a retrieval based approach to keep responses grounded in policy knowledge, so the system not only predicts risk but also explains it clearly to the user. Now I would like Sudhakar to take over.
Thanks, Isha. So on this slide, we demonstrate how a system will ensure both transparency and usability. On the left, we can see explainable AI techniques such as SHAP to identify the most important features influencing the model's predictions. This helps us understand why a particular risk score was assigned instead of treating the model as a whole black box. On the right, we could see the output from a LLM-based assistant. The LLM converts the technical results into simple, human-readable, and user-friendly outputs, and also could answer user queries. For example, it explains the recommended policy, justifies the risk classification and using predicted probability, and also appropriately avoids giving sensitive outputs like exact premium amounts. This combination of XAI and LLM makes the system both transparent and user-friendly. Next slide. So findings and conclusion. So from a user perspective, the system is very simple and intuitive. The user inputs their details, including policyholder and vehicle information, other relevant information. The system processes this data and predicts the probability of a claim. This probability is then converted into risk categories such as low, medium, or high. Based on this, the system recommends appropriate insurance policy. And finally, the LLM provides a clear and explanation and allows users to ask follow-up questions on the same. Next slide. Limitations and challenges. So while the system performs well overall, there are several limitations to this. First, from a modeling perspective, the recall for claim prediction remains moderate due to class imbalance. And the dataset itself presents challenges like including weak features and relationships, unlimited predictive signals. From a system perspective, the LLM component may produce slightly variable responses, and because it depends on the quality of knowledge base. These limitations highlight areas for future improvement for our project. Next slide. So there are several opportunities to improve in this system in the future. From a modeling perspective, we can improve recall by using advanced imbalance handling techniques and incorporating richer data sets. And from a system perspective, the solution can be deployed as a real-time web application with continuous monitoring and retraining. Additionally, the LLM component can be enhanced with better grounding and more comprehensive knowledge base to improve consistency and reliability. Conclusion. So, in conclusion, we developed an AI-driven system for an insurance risk prediction and policy recommendation. This system combines machine learning, explainable AI, with sharp analysis and LLMs to deliver not just predictions but also transparent and interpretable insights. This project demonstrates how AI can transform traditional insurance process into data-driven and user-friendly decision systems. Um, so we also incorporated a CI/CD pipeline into this to select good models based on if you are changing updating the data set. So we thank you from my side.
So here are some references that we used in order to complete our project. Thank you.